Hey everyone. Uh, this is the second part of time value of money. In first part, we discussed the basic of time value of money, and we explained what are the types of interest rate and how they work in the business environment. What is the difference between simple interest rate and compounding interest rate? And then we have uh, discussed what is the basic form of uh, 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 future value, present value, and what is the impact of compounding on the future value, what is the impact of number of time periods and interest rate on the overall compounding value. So we already explained compounding is related with the future value and discounting is related to the present value. And in last lecture, means in part one of time value of money, we covered the present value with the different examples, and we have discussed the future value having different examples, and we have solved the problems. So this is the part two of time value of money, and in this topic, what we will cover. So here we will be dealing with the finding the interest rate, how to find the number of time periods, and later I'll be dealing with the annuity and what are the types of annuities, and then we can deal with the different cash flows. After dealing with the different cash flows, we can go for the amortization of a loan, how we can manage the loan amortization table. So, as we know, present value is called discounting and future value is called compounding. In time value of money, we normally have four components. One is present value, the other one is future value, then interest rate, which is denoted by I or small r, and then we can have the number of time period, which can be denoted by t, small t, or small n. If we have the information of any three of these components, then we can find the fourth one. In part one, we have discussed the future value as well as present value. So today we'll be dealing with how we can find the interest rate and number of time period. So this is the overall quick recall of the last lecture. So basic formula of present value is future value divided by 1 plus interest rate raised power t. As we better know, I, T, F, B, and they are the four component, and out of these three terms, if we have the information of any three, we can find the value of fourth one. So how we can find the interest rate or discount rate, rate of return? So most of the time we are interested to knowing the interest investment rate of return. So we can rearrange the basic equation of future value. So we have the equation future value is equal to present value into 1 plus interest rate raised power t, and our purpose is to find the interest rate. So we can, this present value will be divided here. So future value divided by present value is equal to 1 plus I raised power t. It's power, not the multiplication. So we need to find the interest rates. Then what we can do, we can take power 1/2 on both sides of the equation. So this is the mathematical principle. We can add, we can subtract, we can divide, we can multiply the same expressions on the both sides of the equation. So it will not change its expression, but we can get the relevant value. So we take the power 1/2 on both sides. So t multiply by 1/t, t and t are cancelled. So we left with 1 plus I this side. So we need to find the interest rate or discount rate So plus 1 will be shifted to left side of the equation. So it will be minus. So interest rate formula is future value divided by present value raised power of 1 over t minus 1. So by using this formula, we can find the present value and future value. So we have here we have an example to calculate the implied rate of return or interest rate. For example, if you invest today, means today's present value, and what you want to have, that is the future value, in a specific number of time period, that is the t. So what is the question? Let's suppose an investment that will pay means we will be receiving in some future dates, means after 3 years 1500 if we have 1100 to invest today. So present value in this case today is the present value investment. Once we are talking about investment, at least to present value, and what we will be receiving, that is related to future value. So in this case we have to find the interest rate. So we better know the formula. What is the formula of rate of return? It's future value divided by present value raised power 1 over t minus 1. So in this case future value is 1500, present value is 1100, time is 3 years. It's really discounted. So we can find these values after simplifying. So we can find the interest rate, which is 10.89%. So how we can interpret the results? So we can interpret the results if I have 1100 for investment, and it will grow to 1500 in 3 years if the rate of return or interest rate is 10.89%. So during interpretation, so you have to take care that all four components are discussed. So then we have the discount rate example. We have another discount rate example. Let's consider another investment, and that will allow you to double off your basic investment in 5 years. So what can be the rate of return? So your investment is 8,000 and your target is what you want to receive, which is 16,000, means double of 8,000 in next 5 years. So what can be the rate of return? So what you want to have? You want to have 16,000 in 5 years if you invest 8,000 today. So for today, so in this case 16,000 is future value and 8,000 present value, and number of time periods are 5 years. So raised power 1 over 5 minus 1. So after simplifying, we are having the interest rate, which is 14.869%. So in this case we can interpret, if I want to double 8,000 in 5 years, then the rate of return, the implied rate of return or discount rate should be 14.869%. So now we have the quick quiz related to, if you invest 500 today and you want to receive 600 in 5 years, so what can be the rate of return? What can be rate of return? So in first part, we can determine the rate of return, and we have another option. If you invest $500 in a bank at the rate of 4%. So what is question? What is the implied interest rate in first part? So we can find the rate of return, 600 divided by 500 raised power 1 over t minus 1. We can find the value. So here we have the interest, another option. So here, if we solve this question, we can get it maybe 3.7%. What does it mean? So this first option is providing you the rate of return 3.7%, and the second option, rate of return, is our discount rate is 4%. So which option you will opt? So which investment should you choose? So the investment which is giving you the more interest rate will be selected for your investment. Okay, so in this case, what was the objective? We want to make a comparison between these two options, which is giving you the more value. So the uh, uh, first part, we need to find the interest rate, which is 3.7 something percent, and the second option is having interest rate which is 4%, and this 4% is greater than the first option. So being as an investor, which option you will be going to select? The option which is providing you higher interest rate, you will be selecting. So after that, how we can find the number of time periods? So we can rearrange the basic equation, and we have the basic equation which is future value is equal to present value into 1 plus I raised power t. In this case, we need to find t. So future value, so present value will be shifted, means we will be divided by future value, and here we left with 1 plus I raised power t. So we need to find t, and t is a power, and once we have power, and we need to find that that expression or that component, then we take the log function. This is a mathematical principle. If we take log, then power can be converted to coefficient. So if we, why we are going to take log? Because we need to find t, and t is as a power. So power will be shifted to the it will become a coefficient. So we can take log on both sides of the equation. So in this case, so log of future value divided by present value is equal to, once we take log, this power will be converted to coefficient and log of 1 plus I. So we need to find t, and we can have t this side, then log of fp divided by pv whole divided by log of 1 plus I is equal to t, and t is the formula. So the t we need to find, the log function with log approach we can find t. So in this case, how you will be able to solve? First solve the future value divided by present value, then you take log. Here first you have to add both values, then you take the log. So after taking log, so then log of this value, then you can divide. Sometimes students make mistake, so they can cancel log or log, so it's something different. So here we have an example. Suppose you are looking to spend. So your target, what you want to spend, that is 2,500 for a new car, but currently you have 20,000. Your target is 25,000 for buying a new car, but you have, the moment you have 20,000, so at the rate of 15%, and how long it will take to grow to 25,000. So for example, if you have 20,000 today, and how much time it will grow to 25,000 if the rate of return is 15%. So in this case, we have the 15% rate of return, and our target amount is 25,000, and the given value is, it means today what we have means present value is 20,000, and we need to find the number of time periods, and we have the formula. What is formula? A log of total future value divided by present value whole divided by log of 1 plus I. So in this case, the interest rate is 15%. We can find the value is 1.59 years. So how we can interpret, if we have $20,000, $20,000 will grow to 25,000 at the rate of 15% after 1.59 years. Or we can say if I invest 20,000 today at the rate of 15%, it will grow, or I will be getting 25,000 in 1.59 years. So this can be interpretation. While interpreting the values, you have to focus on all components. So here we have a quick quiz, and we can find the rate of return is 6% and future value is 600 and present value is 500. We can find the number of time periods. So then we have the rule of 72. Rule of 72 is used to find the number of time periods. It's very simple. Why we use the rule of 72? It's used to find the number of time periods when it can be applied if your target means your future value is double of your present value. So then we can use the rule of 72. It's only applicable if future value is double of your present value. Then we can apply the rule of 72 to find the number of time period. So what is the objective? The objective of rule of 72 is to find the number of time periods, and its condition is your future value means the target money should be the double of your present value. How long it will take to double 5,000 at the rate of 12% approximately? So rule of 72, we use the rule of 72. We can solve this question through formula which we have discussed in the last two slides. So or we can use the rule of 72, and as I explained, it can be implied if we have the future value double of the present value. So you understand, hope you understand, and this example how we can solve. So its formula is 72 divided by interest rate. So in this example, 72 divided by interest rate is 12%. 72 divided by 12, we are getting the value. It's 6 years. You will always be getting the rounding values, not exact value. And this is approximate value, not the exact value. So 6 point, if we solve with the formula, okay, manually, so then the exact value is 6.12 years. If we use the rule of 72, we are getting 6 years. So it's approximate answer, but not the exact answer due to effect of rounding. There might be nominal difference between the actual answer and calculated. So in this example, our basic investment is 5,000, and we want to grow it double. Double is 10,000, and the rate of return is 12%. And how we can find these values, number of time periods, we can apply the rule of 72. 72 rule of 72 is suggesting us its the value is 6 years. The number of time periods are 6 years if the rate of return is 12% and our today investment is 5 years. So it will take 6 years to grow it to 10,000, means grow it to double of the basic investment. So this is the time value of money calculator. So we can use time value of money calculator. So here I would discuss the concept of why we are placing minus. So this is minus value is representing the present value. What we can explain the present value? It means present value normally represents the investment, and investment, once we are dealing with the time value of money, one is outflow, the other one is inflow. So outflow is your investment. So in this case, if you want to invest, so if we are going to invest, so the money is going out. So if we receive something in future that in some future date, so we are getting back the money, that is the inflow. One is outflow, the other one is inflow. So we can say the outflow in this case is 5,000, but after 6.12 years, we'll be getting 10,000, means that will be inflow at the rate of 12%. So in this case, We can find the value by using time value of money calculator. So once we are solving the question by formula or manually, so we are not supposed to put the minus sign. This minus is just to give the sense to the calculator or to the Excel file. If you're using the Excel file, so we have to give the sense that minus means the money is present value. That will represent the present value, and it means the money is going outflow. We are going to invest. So if you don't put minus, so the calculator and Excel sheet will consider it as a future value. It means that is the that is the money you will be going to receive in some future dates. So minus is just for sense. What is the logic? This is the investment, and investment is today and it's going out. That's what we put the minus sign here. So the outcome indicates that investment 12% per year can be double in 6.12 years. So if it doesn't matter what kind of investment we have, what is the magnitude, but it should be double of your basic investment. Then we can apply rule of 72, or we can find the exact answer. So in this case, by using the rule of 72, we can get the approximate answer is 6 years, but once we are using the formula, we are getting the answer, which is 6.12 years. So here we have a problem, comprehensive problem. How long it will take your 10,000 to double in value at the rate of 5%. We can find by using rule of 72, or we can use the formula, or we can calculate through the time value of money calculator. What annual rate has been earned if the if $1,000 grows to 4,000? So it means this is dealing with the how we can find the interest rate. Means it's related to interest rate in 25 years. If we invest 1,000 today and we wanna receive 4,000 in 25 years, so what can be the rate of return? Already discussed, so you can solve by yourself. So these are the basic symbols, and these symbols already explained. Present value represent the is considered is represented by PV, and future value is represented by FP, and so on. Already we know these expressions. So here we have the annuities. What is annuity? Before in part 1 and so far whatever we have discussed was the case of single payment. We have discussed the whatever we have discussed so far related to time value money was about the single payment. Now we are dealing with the more than one payment, but all payments are equal. They are the equal payments, that is called annuity. If we have series of equal payments, that is called annuity. So what is annuity payments? Are receipts are a series of equal payments over a specific time period. So is called annuity. And these payments can be made either at the end of time period or at the start of time period. So if we are making the payments series of equal payment, if the start of time period, that is called annuity due. If we make payment at the end of each time period, that is ordinary annuity. So first we need to understand what is annuity. So if we have more than one equal payments, so or we can name it series of equal payments, is called annuity. And these equal payments can be made either at start of the time or either at the end of time. If the payments are made at the end of each time period, we can say ordinary annuity. If the payment is made at the start of time period, so then we can say it's the annuity due. So we have examples here. So what can be the examples of annuities? These can be the insurance, it can be the mortgage, it can be retirement, it can be student loans, car loans payment. So it means whatever what we take loan, or it can be, and if we pay in a uh, different installments, but the amount of installment, magnitude of installment is same, that is called the annuity. So here are different parts of annuity. If ordinary annuity, payments are made. So here is the start time period of first time period, and here is the ending. So the second time period start is here, and here is the end. Third time period start is here, and here is the end. Look at the payments. Payments are made at the end of each time period. If the payments are made at the end, so that is called ordinary annuity. So in this case, the ordinary annuity, because we have equal payments. First of all, we need to understand either it's the case of annuity or not. So it's the case of annuity because we have more than one payments and all payments are same. So we have the equal cash flows. So they are having the three cash flows every year at the end of each time period. The cash flow values 1,000, 1,000, 1,000, but these payments are made at the end of each time period. That's what we name it ordinary annuity. So the same case, we have more than one payments, but the payments are made at the start of time period. So beginning of time period, if you see here, so the beginning of first time period is here, the beginning of second time period is here, the beginning of third time period is here, means at the start of each time period. So that is annuity due. That is annuity due. So remember, if it's case of either annuity due, present value of annuity or future value of annuity, we will be getting the higher value or bigger value, larger value of annuity due as compared to ordinary annuity, because here the payments can be made, payments can be invested if case of future value. So we will be having more value. So the number of time periods will be more. And if it's the case of present, then number of time periods will be more for the case of present value. So here we have the example how we can solve the present future value of annuity. So keep in mind this value here, the payments are made at the end of each time period. At the end of each time period. For example, in this case, so payments are made at the end of each time period. So at the end of each time period, so this 1 year is left. So how many time periods? For example, number of time periods are 3. So how many time periods are left? 2 time periods. For second cash flow, how much time it how far it will be invested? It will be invested for 1 year. For third time, it means there it will be investing for no time period, the same value will be getting. So here we have example. So in simple words, the first cash flow power will be n-1 because already 1 year is already done. So the second cash flow power will be n-2, third cash flow power will be n-3, and last cash flow power will be 0. So if we have the case of annuity and it can be the ordinary annuity or it can be the annuity due, and how we can solve the annuity, either it's case of ordinary or due, we can solve piece at a time. We can solve individual cash flow, single cash flow, and we can solve single cash flow. And the second method is we can use the annuity formula, means group at a time. For example, if we have 25 years cash flow or 25 equal payments, so if we adapt the piece at a time, so it will taking us long to work. It takes significant amount of time to solve individual part. So normally it's preferred we go for the individual group at a time, means by using the annuity formula. So this is the ordinary annuity. The payments are made at the end of each time period. So the first time period is over, then we left with less than n, 1 less than n. So n minus 1 for first, n minus 2 for second, n minus 3 for third, and the last cash flow payment, the power will be 0, because the last cash flow, for example, 3 years, so we will be getting the payment, last payment at third year, so that will be not invested for any more time period, so it means the power will be 0. So look at this example. If we have the series of equal payments, and what is the value of equal payment? So we better know the series of equal payment: 1200 at the end of first year, 1200 at the end of second year, 1200 at the end of third year. So we can get the answer. So the here number of time periods are 3, but the rate of return is 10%. So first cash flow power will be 2, second cash flow power will be 1, and third cash flow power will be 0. So we can simplify, we can find the future value interest factor, we can find the future value interest factor of first cash flow. We know the formula. What is formula of future value? So present value multiply by 1 plus I raised power n minus 1. This is annuity, means first cash flow already we have done. So first cash flow, total number of time periods are 3. So the first cash flow power will be n minus 1. So 3 minus 1, 2. Second cash flow power will be n minus 2. So n is 3, number of years are 3. 3 minus 2, power is 1. And how long we can solve? We can solve if we are having the power 0. So the third cash flow, n is 3, means t is 3, 3 minus 3. So that the power will be 0. So means last cash flow power is 0. After simplifying, how much we will be getting? So we are moving towards the later money. So later money, our direction is towards the future value, means later money. So in 3 years, we will be getting 3,972. If we invest 1,200 at the end of each time period for 3 years at the rate of 10%, then we will be getting 3,972. So how much we are going to invest? 1,200, 1,200, 1,200, total 3,600, but at the rate of 10%. But how much it will grow, how much we can get at the end of 3 years? 3,972. It means the future value is always greater than present value. So in this case, our investment is 3,600 in 3 different years, but the value of investment, or the magnitude of investment, or the size of investment for 3 years is same, and this investment is being made at the end of each time period, and it's giving us the answer 3,972. So you can solve. So first, here is the first cash flow future value, 1,472. Why 14? Because t is more and higher the number of time periods, more will be the future value. Higher the interest rate, more will be the future value. That's what we name it. There is a positive relationship between future value and number of time periods and interest rate. So we can say interest rate, time period directly proportionate, directly have the direct relationship with future value, means have the positive relationship with future value. What does it mean? Larger the time period, more the interest rate, higher will be the future value. Look at this. We have the same payment here. Number of years are 2, power is 2, here power is 1, here power is 0. So the higher the number of time periods, more will be the future value. So 3,972 is future value. So if we have the same hint on an annuity, ordinary annuity, future value occurs at the end of previous cash flows period. So while the annuity due, the payments are made at the start of time period, means the beginning of time period, already we know. So we can solve the time value of money problems with different approaches, 3 to 4 approaches. First approach is we can solve this question through piece at a time, means single individual payment we can solve. Then we can go for the annuity formula. Then the third approach is we can solve the question through interest factor table. So the interest factor future value, this case is related to future value. We can use the future value interest factor table. So what is the future value interest factor table? So in this case, how we can write future value is equal to, it's for, by the way, its formula is R into 1 plus 1 plus I raised power t minus 1 whole divided by I, or we can name it future value interest factor of annuity, I percentage, and number of time periods, those are t. So in this case, what is R? R is series of equal payment. So the example we have, so we have the series of equal payment. It can be denoted by C, it can be denoted by capital R. It's up to you which expression you wanna take. So here, so an ordinary annuity already I have discussed. So we are talking about the future value interest factor table. So it will save your significant amount of time. So if you follow the interest factor table, or you can use the formula of time value money, means piece, not piece, group at a time formula. So here we have the future value interest factor of annuity at the rate of 10% and 3 years. So our concern in this example is, so the percentage is 10 and number of years are 3, 9%, 10%, 11%, 12%, 13%, and so on. Here we have the number of years. Here we have number of years which are in the row, and columns are related with the percentage. So in this case, 10% is the interest rate, and number of time periods are 3. So we can find the value 10% at 3 years. So 3.310. So 1200 multiply with 3.310. It will give us the answer 3972. 3972. So the fourth approach is the time value of money calculator. So here we have the payments on the time value of money calculator. It's we have 5 keys. N represents the number of time period. I is representing the interest rate. So PMT, if we have the annuity case, the payment means it's the series of equal payment. So we normally put the value as a payment. So that is also we consider it minus negative 1200 in this case. But we need to find the future value. It was the annuity case for future value. We are not dealing with the present value. So we need to place 0. If it's the case of present value, instead of future value, we give it the value equal to 0. So this is future value of annuity. And we have series of equal payment, and size of payment is 1200. For number of time periods are 5 years, and the rate of return is 10%. By putting these values in the time value of money calculator, we can find its answer 3972. So if it's the annuity due, what is annuity due? The payments are made at the start of each time period. So start of each time period. So if it's the start of each time period, so the payment is made here. So it is going to be invested for n time period. So first cash flow power will be n. Second cash flow power will be n minus 1. Third cash flow power will be n minus 2. Fourth cash flow power will be n minus 4. And the last cash flow power will be 1. The last cash flow power will be 1. So as we did for the ordinary annuity, what we have the ordinary annuity. So before discussing this annuity due, I want to give you a brief overview of interest factor table. how we can find the values from interest factor table. You are having the interest factor table. So in this table, we have 4 types of tables. So table 1 is related with the future value interest factor, simple means single payment. Table 2 is related with the present value interest factor, single payment. So table 3 is dealing with the future value interest factor, future value interest factor annuity. A means a annuity. uh, for it means we have the series of equal payment. Table 4 is related with the present value interest factor of annuity. So what case we were discussing, that was the case of future value interest factor. If you look at this table 1, so we need to be very vigilant. So normally students make mistake. So they find the extract the value from wrong table. So our case is future value interest. Our case is future value of annuity. So this is the future value interest factor, means single payment. So simple future value interest factor, not annuity. If it's A is written here, that is our concern. So we have to find the future value interest factor of annuity. So that is table number 3. So we move down. So here, what we can see, this is the present value interest factor. It's not our concern. Our concern is future. So again, we look at this part. So new page, present value interest factor. Look at this. This is a future value interest factor. It's related to future value interest factor. If we look at what was the case, 10% for 5 years. So look at here, this is the formula. So interest factor is equal to 1 plus I raised power t minus 1 whole divided by I. So in the last example, what is example? 10%, 3 years. 10%, 3 years. So 1200 are the equal payments. So 10%, here is the percentage. First you select the required percentage. This is 10% for 5 years. So 10% for 3 years. 10% for 3 years. Its year is 3. So 10% for 3 years. Value is 3.310. Value is 3.310. So it's we can multiply 1200 into 3.310. This is the exact value which we are going to find, which is related to our required question. So the important thing is how we can find the exact value. So look at this expression at the top. Either it's the future value interest factor of annuity, present value interest factor of annuity. Either it's the case of simple present value or simple means single payment present value or single payment future value. For example, we have discussed more the time period, means larger, more are the number of time periods, or higher is the interest rate, more is the then larger will be the future value. And this higher future value is depending on the interest factor. So in this case, interest factor is if we see, for example, if we see the number interest rate is increasing 5% to 12%. If we consider number of time periods are 3 and interest rate is 11%, 11%, you see the value is bigger than the 10% value. If interest is increased 12%, where the interest factor value is bigger than the last interest factors. So if we increase the interest rate, future value will be increased. That increases due to the increase in interest factor. If we have higher the number of time period, for example, 10%, 3 years, 3.310. If 4 years, number of time periods are increased, value is increased. Number of time periods are increased means 5 years. So a percentage is same. So the interest factor value is increasing, means more the time period, more is the value. That is positive relationship. So this was the time value of money table. So if it's the case of present value of annuity, we consider this table. If it's the present future value of annuity, we we have to consider this expression. If it's the single payment case, so if it's the having the future value of single payment, so we can consider the future value interest factor at a specific interest rate for a specific time period. So I resume the ordinary annuity we have done. Now we can talk about the annuity due. And what is annuity due? So in this case, so the payments are made at the end, at the start of each time period. So the first payment is being invested. First payment is being invested for n number of time periods. So the first cash flow power will be n. Second cash flow power will be n minus 1. Third will be n minus 3. And the last cash flow power should be 1. Because where should be 1? The last cash flow payment is made at start. If it's made at start, so it means that is invested for one time period. So here we can solve the same question. We have 1200, the series of equal payment at the rate of 12%, 10% for 3 years, but the payments are made at the start of each time period. So first cash flow power will be 3, second cash flow power will be 2, third cash flow means power will be 1. So as I explained, so the last cash flow number of time periods are 3, so the last cash flow power will be 1. So more the power, more the time period, more is the value. So power 3 we are getting bigger value, power 2 we are getting smaller value, power 1 we will be getting less value. So in the end, after finding these values, we can add these future value of these cash flows, which are the total, which give us the sum. The sum means the overall cumulative value is equal to 4369.2. So why this answer is bigger than the ordinary? Because we have more time periods of each cash flow, and each cash flow is invested for one extra time period. So that's what, more the time period, more will be the future value. So what is the sum of rule of thumb? Annuity due value will be more as compared to ordinary annuity, because due is invested for more time periods as compared to ordinary. So same approach, we can solve the question by using the time value of money table, introspect table. What you can do? So it has the same formula as we did for ordinary annuity. What we need to do, we simply multiply 1 plus I. So we have in this case 1200. 1200 is the series of equal payment. We have future value interest factor of annuity 10% multiplied by 10% at 3 years. So its answer, the interest factor is 3.310, but multiply by 1 plus I. Why 1 plus I? Because it's being invested for one extra time period, because payments are made at the start, and it's the case of annuity due. So we can solve this question, and we are getting the value that is 369.2. So this is the annuity due. So for example, if it's the ordinary annuity, so what we can do, what answer we find here, we are finding 3972 multiplied by 1.10, interest rate is 1.10, that give us the answer 4300 something. It means it become the annuity due. So after that, we have the present value of annuity. So the present value of annuity, it has the same approach, but we need to find the today value, means earlier money. Here look at, payments are made at the, we will be receiving same amount of payments for different time periods but the payments will be made at the end of each time period. So the first time period payment is here. So we can find the present value of first time period. Say for first time period, so the power is 1. Second time period, power is 2. Third time period, power is 3. And last time period, power is n. So, but in this case, we are going to find the present value, and we know the formula. Present value is equal to C divided by 1 plus I. Means the same approach. Present value formula is C divided by, or we can say payment divided by 1 plus I. For future value, payment multiplied by 1 plus I raised power t. So in this case, the present value, so it will be formula as means series of equal payment, means payment, it can be denoted by capital R or it can be denoted by capital C. So the payment divided by 1 plus I raised power. So for first cash flow, power is 1. For second cash flow, power is 2. For third cash flow, power is 3. For n cash flow, power will be n. You can see. So we can solve this present value of annuity by piece at a time, means single individual cash flow, or we can go for the present value of annuity formula, or we can go for the present value in interest factor of annuity, or we can solve with the time value of money calculator. So in this case, the same question, payments are made at the end of each time period, but we need to find what we will be getting at the end of first time period. We'll be getting 1200. At the end of second time period, we'll be getting 1200. At the end of third time period, we'll be getting 1200 at the rate of 10%. What's their value today? So total, we will be getting 3600 in 3 years at the rate of 10%. What's their value? What's their overall magnitude today? So first time period cash flow, power will be 1, second will be 2, third will be 3. Here is the concept. More the time period, less will be present value. So you can see the first cash flow power is 1. We are getting 1090. Second cash flow payment is same, but the power means number of time periods are more. The value is present value less. Third cash flow, number of time periods are 3, but rate of return is same. So n is increasing, t is increasing, then future value, present value will be low. So you can see here 12 divided by 1 plus 1.10. 1.10 is interest rate risk power 1. For second cash flow risk power 2. Third cash flow risk power 3. So in the end, what we are getting 2984.20. So in 3 years, we will be getting 3600, and each year, at the end of each year, if we get 1200 for 3 years at the rate of 10%, its present value is, its today value is, its today worth is 2984.20. Hope you understand. So if it's the annuity due case, we simply multiply 1 plus I. So we simply multiply 1 plus I. If the case is annuity due, so here will be the payment. So the first cash flow power will be 0. Already discussed, we can find the value from the time value of money table. So it's the present value interest factor at 10%. Now we are dealing with present value. Be vigilant. You should be take extra care. You need to take extra care while finding the value. So number of years are 3. Interest rate is 10%, and at 10%, 3 years 2.48. But it's the case of present value interest factor, not the future value. So you need to look at the present value interest factor of annuity is table number of 4. So 10%, 3 years 2.487. So we can find the value, and it's giving us the value 2984.44. So if we solve manually, means single cash flow 2984.2. If we solve through interest factor table, we are getting 2984.4. There might be decimal difference. Difference in decimal means a nominal difference. So that is due to the effect of rounding the values. We can solve the time value of money calculator. Number of time periods are 3 and interest rate is 10%. Series of equal payment, magnitude is 1200. It's case of present value, not future value. So for future value, we put 0 and it's case of present value. So it's giving us the answer 2984.4. So this is the present value. If it's the case of due, the payments are made at the start of each time period. So here is the payment of first cash flow. Here is the payment of second cash flow. Here is the payment of third cash flow. The payments are made at the start of time period. If it's this cash flow, first cash flow, power will be 0. Second cash flow, power will be 1. Third cash flow, power will be 2. And the last cash flow, power will be n minus 1. So look at here. First cash flow means equal payment divided by 1 plus I raised power 0 because it's on the first cash flow. Here time is 0. Second cash flow, it's the start point of second cash flow is here. So power is 1. Third cash flow start is here. Power is 2. And the last cash flow n minus 1. So n is here. So this is n minus 1 place. So the same example, we have 1200 for 0 time period, 1200 for 1 time period, 1200 for 2 time period. Number of time periods are increasing. We are getting the lower present value. So the total, if we sum up these values, present value of each cash flow, if the payments are made at the start of time period, then we are getting 3262.63. So always, as I explained, always we will be getting the higher payment of annuity due as compared to future, as compared to ordinary annuity. So the value of annuity due is more than the value of ordinary annuity. So we can find individual, or we can apply the time value of money table or interest factor table. So 10% for 3 years. So it means what we found for the ordinary 2984 multiply 1 plus I. So we are getting the value here. So we use the same formula, 2.487 multiplied by 1 plus I. So 3282.84. So this is the value of present value of annuity due. So here we have the formulas. If you don't have the table, so what is formula of present value? Present value of annuity. So this is CRR, both are same thing, means series of equal payment, it's size of payment, magnitude of payment. So that is the example we took, it's 1200. 1 minus 1 divided by 1 plus I is 10% in the example which we have discussed in last few slides. And D is 3 years, we can determine the values. And future value formula is 1 plus I raised power T minus 1. So divided by R. So the expression which is in braces or bracket, okay. So this is called the interest factor, present value interest factor of annuity. So in this case, for future value, interest factor of annuity is 1 plus I raised power T minus 1 divided by R. And this interest factor value we can find from the table. So it's due, we simply multiply with 1 plus I. So here we have the interest factor of ordinary. So 1 minus present value interest factor of annuity ordinary, 1 minus 1 divided by 1 plus I raised power T. So future value interest factor of annuity ordinary, 1 plus I raised power T minus 1 whole divided by I, or R. I and R are same things. So then we have the present value interest factor of annuity due. What we simply do, we simply multiply with 1 plus I. So we have future value interest factor of annuity due. So we simply multiply 1 plus I. Then we have another concept which is related to if we have different cash flows. So we started our discussion from single payment, then we have more than one payment, but these payments are same throughout the given specific time period. In this example, in this part, we are dealing with the mixed cash flows or different cash flows. If we have different cash flows, how we can solve? So in this example, we can see the example is, for example, we have different cash flows. First time period 500, second time period 500, third time period 300, fourth time period 300, and the last time period 100. So in this example, we have the different cash flows, and these different cash flows are giving us the how we can solve. We can solve by two methods. One is we can individually solve. We can solve this cash flow. This cash flow is invested for one time period. 500 is, if we are going to find present value, so we can use the formula 500 divided by 1.10 raised power 1, 500 divided by 1.10 raised power 2, 300 divided by 1.10 raised power 3, 300 divided by 1.10 raised power 4, and 100 divided by 1.10 raised power 5 means a single payments method you can apply. So if we have different cash flow, it can be solved by two methods. One is piece at a time. So then discounting to till zero, time zero. What is time zero? So if it's the case of present value, it means we need to find the value here at zero. If it's the case of a future value, we need to find the value here, means towards n. So the second approach is group at a time. If we are talking about group, so it means we have more than one equal payments, more than one equal payments. If we have more than one equal payment, that leads us to annuity. If the payments are made at the end of time period, that will be the ordinary annuity. If the payments are made at the start of time period, we name it annuity due. So for each group, discount to zero and already explained. So the example which we have 500 at 10%, 500. So how we can solve 500 divided by 1.10 raised power 1 divided by 1.10 raised power 2 already discussed. So here we have the this is the piece at a time. We are solving individual cash flow as a single payment method. So single payment method is cash flow value divided by 1 plus I raised power 1 per second divided by 500 divided by 1.10 raised power 2, 300 divided by 1.10 raised power 3, 300 divided by 1.10 raised power 4. Here is the 100. So in the end, how much we are getting? 1360.14. So how much we will be getting in 5 years? So 500 plus 500 plus 3, 5 plus 5, 1000 plus 300, 1300 plus 300, 1600 plus 100, 1700. In 5 years, we will be getting 1700 and each year, and we are having different values and different years. So we'll be getting 700 at the rate of 10%. Their today values, their today what is means their present values 1360.14. The second approach is mix of mixed cash flow, or we can name it group at a time. So we have simultaneously or continuously more than one equal payments, 500, 500. So it means we have the annuity. So what is the means payment size is 500. It's the case of present value. So 500 into present value interest factor of annuity 10%. For how many time periods this payment is made? This payment is made for 2 time periods. So it means the T is 2 here. T is 2 here. 500, 10%, 2 years. the value at present value interest factor of annuity at 10% for 2 years is 1.736. So it's giving us the answer 868. So this is the first group, 500 at first year, second year 500. So it becomes a group, and if it's a group, then we can go for the annuity. So this is the case of present value of annuity. So we can solve through annuity. So the second group is 300. So the size of payment is 300. So how we can solve 300 into present value interest factor for how many time periods? 2 time periods. So 10% for 2 time periods. So keep in mind, if we have the group means more than one group in the timeline, and the first group, second group is simultaneously, then for how many time periods the group is then we can multiply. We have to multiply with the present value interest factor of simple, because they are for 2 years 300 and 300. So they are the we need to multiply the interest factor of simple for 2 years at 10%. So present value interest factor 10% for 2 years. So here is the payment size is 300. The interest factor, present value interest factor of annuity at 10% for 2 years is 1.736. But the present value interest factor simple, one is annuity, the other one is simple, is 0.826. So we are getting the payment of these two cash flows, means this group is equal to 430.18. And we left with the one payment, and it's at the 5th year. So we will be solving it for a simple payment method. So present value 100 into present value interest factor, it's not group. So we will be solving it as a simple present value interest factor. It's 100. So at 10% for 5 years, because this payment is going to be made at 5th year. So its value is present value of 100 at 10% at 5 year is $62.62.110. So this was the method how we can solve the different cash flows, cash flows if we have different payments. So we can solve as a piece at a time or group at a time. Then we have the compounding, frequency of compounding, how it's important with the future value. So in this case, if we have the compounding less than annually, or annually it's okay, we have done with the case of annual. If it's less than annual, because for example, it's semi-annually, means twice in a year. Quarterly means it's 4 times in a year. Bi-monthly means it's 6 times in a year. Then monthly means 12 times in a year. Weekly means it's 52 times in a year. And daily means 365 times in a year. Simple is that if the frequency of compounding is less than annual, what we need to do, this frequency is denoted by small m. What we need to do, we divide the interest rate with frequency of compounding, and we multiply the number of time periods with the frequency of compounding. It means we convert the interest rate into the compounding frequency, and we convert the number of time periods with the frequency of compounding. So we better know future value is equal to present value into 1 plus I raised power t. This is the for annual, if it's annually compounding. If it's less than annual, what we do, for example, semi-annually, so 1000 in this example. So for example, if we made 1000 to invest for 4 years at an annual interest rate 10%. So for annual, either we divide or not divide, so we will be getting the same value. If it's less than annually, means semi-annual, so I is divided by 2 and time is multiplied by 2. means time will be multiplied with the frequency of compounding, and I will be divided with the frequency of compounding. More the frequency of compounding, more will be the, you will be getting the bigger value, means more will be the future value. For example, quarterly frequency of compounding is more, and I will be divided by 4 and time will be multiplied with 4. We are getting the larger value. If the frequency of compounding is further increased to monthly, to increase from quarterly to monthly, so how many months in a year? 12 months. So I will be divided by 12 and time will be multiplied with 12. So we are getting the bigger value. So more the frequency of compounding, higher is the, means larger is the future value. So look at this. The frequency of compounding is 4. We are getting 1484.5. The frequency of compounding is 12. We are getting 1489.35. If the compounding frequency is increased to 365 days, means we are getting the bigger value. So what is the sum up? The sum up is, if we have the compounding less than annual, so the interest rate is divided by the frequency of compounding, and time is multiplied with the frequency of compounding, and more the frequency of compounding, bigger will or larger will be the future value. So the last part of this topic is related to amortization table. So once we go for the borrowing a loan, how we can manage an amortization table. So we have 5 steps in this case. So we can simplify. First of all, if I borrow a loan, so it means I have some money today. It means that is the present value. If I borrow some money, it means I have some payment, that is the present value. So what I need to pay, if I borrow a loan from a bank, so then I need to return the equal installments. So more than one installment, but the payments are same of each installment. It means that is the series of equal payment. If it's series of equal payment, what does it mean? It means we are dealing with the case of annuity. So what are the steps? So case of annuity, and it's the present value, because I took a loan today and I have money and I need to return back in different installments, in different payments, in different more than one payments, and the size of payment will be same. What are the steps? First of all, we need to find the, calculate the payments, means series of equal payment. So far, after the second step, we need to calculate the interest rate, interest amount. How we can find the interest amount? So it can be the last time period balance. Last means last time period balance multiplied by the interest rate. So third step is find the principal amount. How we can find the principal amount? Payment, what we have means installment, series of payment, minus interest amount, minus interest amount, which is calculated in step 2. So the left will be principal, means installment, means payment, minus interest amount. So that will give us the principal. And fourth step, we find the remaining balance. How we can find? Last time period balance minus current time period principal amount. So it will give us the balance. Okay, last time period. So in example, it will be more clear. Last time period balance minus current time period principal, whatever we find in step 3. So step 5 is repeat the process from step 2. We have example, if we borrow 10,000, if I borrow 10,000 at the rate of 10% for 5 years. So we amortize the debt if yearly payments are paid 5 years. So it's yearly payment. So I can have the amortization table. So in this case, what are the steps? So I borrow, it means I have this 10,000. This is the present value I have. So what I need to pay, I need to return this borrowed amount in equal installments for 5 years at the rate of 10%. What are the steps? First step is calculate the payment. Calculate the payment. How we can calculate? We are very sure, we better know. It's the case of uh, present value of annuity. So present value of annuity formula is equal to payment, which is denoted by R, into present value interest factor, I percentage and years. So today how much I have borrowed, it means I have this amount 10,000. I need to find the value of R, means payment, series of equal payment. So present value interest factor 10% for 5 years. We can find this value 10% for 5 years. Present value interest factor of annuity, which is equal to 3.791. So we can find the value of R or C. So the C value is 2638. So I will make series of equal payment, but the payment size will be 2638 for how many times? For 5 years. So at the end of first time period, I will pay 2638. At the end of second time period, 2638. Third time period, 2638. Fourth time period, 2638. 5 time period, 2638. So this is the equal payments for 5 years. So this payment I found based on the present value interest factor table. So here is the amortization table. So what we draw, so ending, so here are the years, okay, is starting from, for example, I borrow the money today, so it means time is 0. So how much I borrowed? So second column is related to payment, third column is interest, fourth column is principal, fifth is the ending balance. So today time is 0, I borrowed 10,000. So I need to return back 10,000 in 5 years. So I left with to pay 10,000 for 5 years. So first time period, second time period, third time period, 4 years, 5 years. And how much is my installment or equal payment? 2638, first time period, second, third, fourth, up to 5 time periods. This is first step. First step, find the payment. What is second step? Determine the interest amount. How we can find the interest amount? Last time period balance. So what is the balance in ending? Means last time period 10,000. What is interest rate? 10%. 10,000 multiplied by 0.10. It's 1,000 is the interest. What is second step? Second step is find the interest payment. Interest payment, how I can find the interest payment? Last time period means balance, ending balance, multiply by interest rate. So it's 1,000. So the third step is to find the principal amount. How I can find the principal? Payment minus interest. So how much I have paid? 2600. How much I have paid the interest? 1,000. How much is remaining? That is 1,638. That is the principal amount. And this is third step. What is fourth step? Find the balance. So it means last time period balance minus principal amount. So the last time period balance was 10,000, and the principal what I have paid here 1,638. So I left to pay 8,362. What is step 5? Repeat the process from step 2. We have found the payment. So what is step 2? Interest rate. So how we can find the interest amount? Last time period means ending balance multiply by interest rate. So we left to pay 8,362. Interest rate is 10%. So it means 836.2 is the interest payment. How much total installment we have paid? 2,600. Out of 2,638, 836.2 is the interest payment, but the remaining will be the principal amount. So if we subtract 836.2 from 2638, we left with 1801.8. So that is the principal amount. And what is the fourth step? Fourth step is the finding the ending balance. How we can find the last time period balance is 8,362 minus principal amount of current time period is 1801.8. So we left with 6560.2. So repeat the process for the next step, means step 2. So we left with the balance here. If we see at the end of second time period, 6560. So 10% is interest rate. 6560 multiplied by 10%. So it will be 656.02. That is the interest payment. So this interest payment is subtracted from the installment. So we left with 1981. So it will be the principal amount. It will be principal amount. Then we can find the ending balance. How we can find the ending balance? Last time period balance minus principal amount paid. So last time period amount minus current time period principal amount, we left with 4,578.22. So repeat the process. So we left to pay 4,578.22. So the interest rate is 10%, 457.7822. That is the interest payment. Then what we total paid, 2638. This minus this amount, we left with 2180.18. This is the principal amount, and this principal amount will be subtracted from the ending time period balance. So 4,500 of the last time period balance minus this amount, we left with 2,398. What is interest rate? 10%. So here 239.8% is the 2,039.8 is the interest payment, and it will be subtracted from 2,600. So we left with 2,398. So the last time period ending balance should be 0. Sometimes you will be unable to find the 0 here. There might be a nominal difference, means 5 values, 3 values, means 1 digit value, or 2 digit values, means 2 digit means more than 10, 10 or more than 10, 1 digit less than 10. So that might be the, here you might have some difference. That is the effect of rounding. So in the sum up, how much total is paid? 13,190. 10,000 is the borrowed amount which we have returned, plus interest. 3,190 is the interest. So total we have returned on our on the borrowed amount 13,190 if the rate was 10%. So in amortization, the beginning payments means at the start more interest is paid. You see, at first time period interest is paid more, but less is the principal payment is less. So number of time periods are increasing, interest payment is decreasing, but principal is going to be increasing. So this is the overall mechanism which is used to calculate the amortization table, amortizing the loan. Once you are going for a loan, you can make the amortization table. If you know the number of time periods, if you know the discount rate, you can find the amortization table. So this was about the overall second part of the topic. So here you can solve this question. 15, if you borrow 15,000 at the rate of 12% at the for the 4 time periods, then you can amortize your loan. So find what is first step, find the payment. Second step, find the interest rate, interest amount. Then third step is find the principal amount. Fourth is finding the ending balance, and fifth is repeat the process from step 2. you can follow this example. So this was all about today lecture, and this was the second part of time value of money, and it was pending with me since last, pending with me by a long time. So hopefully this lecture will help you. So I wish you best of luck and see you in next lecture. Take care.